So anyways, our speaker is Olga Bane. She is a senior data scientist at JW Player, and she has a PhD in molecular biology and genetics. And for the NEM-focused code of conduct, please, everyone be nice to each other. And since this is about her, I will let her kick things off.
So as Steven said, my name is Olga Bane. I am a senior data scientist at JW Player, and I'll be talking today about some predictive modeling that we did for our video advertising marketplace. So JW Player is a video technology company, and we power video for over 12,000 leading publishers and broadcasters. We are actually the #1 source of video views on the open web outside the walled gardens of Facebook and YouTube, and we see hundreds of millions of video plays daily across the world. We use our scale to build data products to help our customers. So we have a recommendations product that helps surface relevant videos. We have an article matching product that helps publishers add relevant video to any article. And the product I'll be talking about today is our video ad targeting product, which helps advertisers identify high quality ad impressions across our publishers' sites. So a lot of our publishers monetize their video content with ad impressions. I told you that we see hundreds of millions of video plays daily. We also see hundreds of millions of ad impressions daily. And JW Player runs an advertising marketplace that allows publishers to auction their ad opportunities. And here's how that works. So a video player on one of our publishers' sites will send an ad request that indicates that there's an ad slot that can be filled by an advertisement. And then advertisers will bid to place an ad impression. And so maybe Apple is very interested in placing an ad impression in the slot, and they'll bid a lot of money. Let's say Amazon is also interested but willing to pay a little less, and Geico is not interested in placing this impression. Apple will win this auction and will place their impression in this ad slot. So why do these advertisers use our marketplace in the first place? Well, it's because they are very often interested in targeting specific segments. So a lot of advertisers want to place their advertisements in front of people in specific geolocations. Some advertisers also want to target certain video categories, and other advertisers want to make sure that the videos that they're placing their video ads on are brand safe. And this context is known when the video player embeds on a page. So for this video, we might know that the viewer is in Canada, the video category is home and garden, and this video is brand safe. And so advertisers are going to use this information at the time of the ad request to determine whether they should bid to place the ad impression and how much they should pay for it. And in addition to context, advertisers are also really interested in hitting certain ad performance targets. So if an advertiser pays to place an ad, they would prefer that the viewer who's watching this ad is engaged. And there are several metrics of ad engagement that are used. So some advertisers care about ad viewability, and there's a couple different standards for how to measure that. Other advertisers care a lot about ad completion, and some are monitoring whether their ads are audible and viewable and complete. And so an advertiser might set an ad performance goal for a campaign that says the goal is for 70% of ad impressions placed to be viewable by the IAB standard. And the tough thing here is that ad performance is unknown when the video player embeds on a page. We don't know whether the viewer will watch the ad, and we don't know whether the viewer will complete the ad at the time that this player embeds. And so typically, if advertisers care about ad performance, they're going to use historical ad performance data to inform their buying decisions. And here's how that might go. An advertiser might set a certain ad performance goal. They'll say, we want an ad IAB viewability to be greater than or equal to 70% for this campaign, for example. And then an ad slot will become available on a video playing on a specific page domain. The advertiser will look at the historic page domain level IAB viewability and only bid to place an ad impression if the historical viewability rate is greater than their target. And so what this means is that advertisers are making buying decisions at the level of the page domain. So I'm plotting here impressions per page domain versus ad IAB viewability rates on this page domain. So each dot here is a single page domain. And if we have a campaign that wants to hit an ad IAB viewability greater than 70%, then this advertiser will typically only bid to place impressions on those page domains with a viewability of greater than 70% historically, and they're going to ignore all these page domains to the left. And so we wondered, can we use data from the video player to improve ad performance prediction? And we actually built models for 5 different metrics. So we built models for 3 viewability metrics, as well as ad completion and ad audible and viewable and complete. And today I'll just talk about one of these models, which is a model predicting ad IAB viewability. So ad IAB viewability is defined as 50% of the ad in view for 2 consecutive seconds. This is a metric that's very often measured by advertisers, so this is where we started. And so our vision here is to predict whether an ad will be viewable at ad request time using signals available prior to the ad request. We're going to do this at ad request time because this is when the advertiser decides whether or not to bid to place an ad impression. So we need to make the prediction before that. And we're going to be using signals available prior to the ad request because this is the only information that the player has access to. We're going to compare this prediction to the advertiser's performance goal, then to determine whether the advertiser should bid to place the ad. And the reason that we can build these models is because we collect data from the player on every video play and every ad impression, so we know what happened on each video play and ad impression, and we can use this data to train and test our models. So I told you that advertisers typically use historical page domain level ad viewability data to predict whether the ad will be viewable. And so this is a feature that I'm going to use in the baseline model to predict whether the ad will be viewable. In our real-time model, we're going to add some very useful features that are only known to the player. So first of all, because we are the player, not only do we know ad viewability across a page domain, we also can calculate ad viewability for each individual video. So we're going to add that as a much more granular historical metric. And then we'll also add in some real-time signals from the player and predict, will the ad be viewable? So our workflow here is that first we're going to identify those real-time signals available in the player prior to the ad request. We're going to train and test the model on yesterday's impressions. And we're going to determine which signals are predictive of ad viewability. And for those real-time signals that have some predictive power, we can broadly bucket them into one of 3 categories. So the first is player state. This is things like player viewability or player size. The second is context. So things like what country the viewer is in or what device they're using, and also user behavior. Is this the first video that the viewer watched, or have they watched a lot of videos? And what was their engagement, for example, on previous ads? And so in principle, we can use any number of models to try and predict ad IAB viewability, but we do have some preferences. A simple model is preferable if it has enough predictive power. It's going to be easier to actually implement in the player. It's going to make predictions faster. And we also prefer an interpretable model. This is going to make it easier for us to understand which signals have predictive power. and understand how offline performance compares to online performance. And it's also definitely going to help us troubleshoot any unexpected things that we might see once this model is actually making predictions in the wild. And so all of this led us to use a logistic regression model to make this viewability prediction. And we expect our real-time model to outperform the baseline for the following reason. So as I told you, using the baseline model, we're going to make decisions at the level of the page domain. Let's take two page domains, A and B. Page domain A has a relatively low historical ad viewability, and page domain B has a relatively high historical ad viewability. Our baseline model is going to predict every ad on the page domain A to be not viewable, and it will predict every ad on page domain B to be viewable. Our real-time model is going to allow us to identify high-quality impressions on this otherwise lower quality page domain A, and it should also allow us to identify impressions that won't be viewable on page domain B. And this is because we make predictions for each ad request using features specific to that ad request. And if our real-time signals really improve predictions, then this top row should mean that we identify more viewable impressions, and the bottom row means that we should reduce non-viewable impressions. This is going to impact both the scale of the campaign and the performance of the campaign. In data science terms, when we talk about campaign scale, we're really talking about recall. So of viewable impressions, how many did we correctly identify as viewable? And when we talk about performance, we're talking about precision. So of those impressions that we predicted would be viewable, how many were viewable? And so these granular predictions are going to allow us to identify high quality impressions on otherwise excluded domains. So whereas with the baseline model, an advertiser might totally ignore all the domains with an ad ID less than their target, our real-time model should allow them to pick out those high quality impressions even on these domains. And so here I am showing the results of our offline model training and testing. And I'm plotting here viewability versus scale. So ideally, we want to maximize viewability and scale for every single campaign, meaning we want to be in the top right-hand corner of this plot. But there is always a trade-off between the two. If a campaign asks for really high viewability, then they will have lower scale. But the important point from this plot is that at every value of scale, the real-time model achieves a higher viewability than the baseline. And at every value of viewability, the real-time model achieves a higher scale. And so what this means is that if a campaign, for example, asks for 75% viewability, with the baseline model, we would be able to identify just under 60% of high-quality ad impressions, and our real-time model identifies almost all of them. If a campaign asks for 80% viewability, then this increase in scale becomes even larger when we look at our real-time model compared to the baseline. So our offline model training looked really good, and we put this model, we did sort of some work to implement this model to make predictions online. So we are training the model daily on yesterday's impressions server side. We're using the scikit-learn library and Python. We're Dockerizing model training and scheduling it daily on Airflow through Airflow, and then our models are serialized to S3. And then client side, we have a plugin that we call the inference plugin that's going to measure those real-time features that are required for the model. It's going to combine those features together with any pre-computed historical measures that we use in the model, and it will make predictions at ad request time. Currently, it's making hundreds of millions of predictions daily and influencing a lot of buying decisions. And of course, now that it is making predictions out in the wild, we need to evaluate how the model is performing online. This is especially crucial because there are key differences between our offline training and online model performance. So our model is trained and tested across the whole JW Player network, but a single ad campaign places impressions on only a subset of videos playing through our player. This is because a lot of times on top of ad performance, campaigns are also targeting other segments. So this is going to narrow the scope of, or the impressions that they might place an ad on. And also, even if a campaign bids to place an ad impression, they don't always win that auction. And so all of this is really impossible to simulate offline. So when we did look at online model performance, we saw that the real-time model did outperform the baseline strategy for campaigns with a relatively high ad IAB viewability requirement. So here I'm plotting again viewability versus scale for just 2 campaigns. The dotted line is the ad viewability requirement. In this case, both campaigns are asking for 70%. In gray is what the baseline model would have achieved in terms of viewability and scale, and then blue is what our real-time model achieved. You can see that for both of these campaigns, the model achieves a higher viewability, as well as the real-time model also identifies more high-quality impressions for these campaigns. We also had some campaigns that required a fairly low ad IAB viewability rate relative to the viewability across our network. And we saw here that our real-time model and the baseline strategy actually achieved really similar performance and scale. And this was expected. So if the viewability that's required is much lower than the viewability across our network, then achieving this viewability requirement is easy. Both models outperform on viewability, and both models identify almost all of the high quality impressions. And so if I now combine model performance over all campaigns and overall impressions, we can compare how the baseline and real-time model performed overall in terms of viewability and scale. On viewability, we improved viewability a little bit from the baseline of 69% viewability. Our real-time model achieves 75%, but the real gain here is in the scale. So with the baseline model overall, that model could identify just under half of the high quality impressions, and our real-time model identified almost 80% of those high quality impressions. So this marketplace should benefit both advertisers and publishers. Advertisers can use our data to target specific audience segments and to reach an engaged audience. And publishers should get more ad revenue because advertisers are willing to spend more money on high quality ad impressions. So this model was running online, and we were training the model every day and seeing a lot of precision recall curves or viewability scale curves that look as expected, which is what I'm showing on the left, where the real-time model outperforms the baseline. And then one day we saw a precision recall curve that looked very strange, where there's this dip in precision, and this is actually true for both the real-time model and the baseline models. And after a lot of research to figure out what was going on, we found the source of this edge case, which was the following. So both our real-time model and the baseline model have this historical domain ad viewability feature. And we're taking a 7-day average of historical domain ad viewability for this feature. And then our train and test set comes from day 8. And so on this day 8, with this edge case, there was one single large publisher that had a really significant drop in historical domain ad viewability that the model couldn't account for. And so to mitigate this, we added one additional feature to the model. In addition to this existing 7-day average historical feature, we also added a divergence feature where we subtract the previous day's historical domain ad viewability from the 7-day average. For most page domains, this number is going to be close to 0, but in cases where there is a big difference between this most recent ad viewability metric, we're going to allow our model to account for this. And so on the left, again, is the precision recall curve that we expect. In the middle is this precision recall curve that we saw one day. That looked very weird. And now if we add the divergence feature to our model and train and test that model on the same data set that resulted in this edge case curve, we see that we can restore model performance for both the baseline and the real-time features, or the real-time model, sorry. So up next, we are building a series of feedback loops to dynamically adjust decision thresholds. So currently, we take the model's prediction and we compare it to the advertiser's performance goal to decide whether the advertiser should bid on this impression. That means that if our prediction is 70% for an impression and the advertiser asks for anything below this requirement, then we'll call this a high quality ad impression for this campaign. This means that the performance goal is a static decision threshold, and this strategy very often results in these cases where we achieve a much higher viewability with our model than the campaign is asking for. So here's one example where the campaign asks for 65% ad viewability. Our model achieves higher than 90% viewability.
Hey, Olga, we're down to the last 5 minutes. We've got a couple of questions. You want to start tackling them or finish up?
Sure. I just have one more slide after this, and I'm happy to answer questions.
Cool.
Yeah, so we're building a series of feedback loops that are going to decrease this viewability back toward the performance requirement, and this will allow us to increase campaign scale even more. So just to summarize, we have an advertising marketplace that should benefit both publishers and advertisers by identifying relevant, high-quality ad impressions. We can use real-time signals from the video player to predict ad performance ahead of an impression. If advertisers use our real-time predictions, they can reach their performance goals and maximize scale. And some really careful monitoring allowed us to identify and mitigate an unexpected edge case. Thank you for listening. I'm happy to take questions. I do want to just mention quickly that we are hiring on our team a senior data scientist and a product analyst. We also have a few data engineering roles open. So if you're interested in any of those, please contact me. But yeah, happy to take questions.
Oh, cool. All right, I've got a couple that came in through the chat. How do you get the data about ad impressions for the model?
So we send data back during the course of a video play. And we also send data back during the course of an ad impression. So we know, for example, when an ad impression happened, was it viewed? Did someone scroll away? Did they complete the ad? So we collect a whole bunch of data from every single video play.
Thank you very much for your time. Is there anything else you'd like to add before we wrap up? Because it looks like you're the last speaker in this particular session.
That was all for me. I'm very happy to move over to Slack if anyone has any additional questions.